Electron configurations. The arrangement of electrons in an atom is known as the atom's electron configuration. The lowest energy arrangement of the electrons for each element is called the element's ground state electron configuration. There are three basic rules of principles that electrons follow when filling orbitals. The first rule, the Aufbau principle, shows the order in which electrons occupy orbitals. The Aufbau principle states that an electron occupies the lowest energy orbital that can receive it. The orbital with the lowest energy is the 1s orbital. The second rule, the Pauli exclusion principle, reflects the importance of the spin quantum number. According to the Pauli exclusion principle, no two electrons in the same atom can have the same set of four quantum numbers. The principle, angular momentum, and magnetic quantum numbers specify the shape, energy, and orientation of an orbital. The third rule, Hund's rule, requires placing as many unpaired electrons as possible in separate orbitals in the same sublevel. According to Hund's rule, orbitals of equal energy are each occupied by one electron before any orbital is occupied by a second electron, and all electrons in singly occupied orbitals must have the same spin state. There are three ways to indicate electron configuration. In the first method, orbital notation, an unoccupied orbital is represented by a line __ with the orbital's name and main energy level written underneath it. An orbital with only one electron is represented by a line with an arrow on top of it pointing upward. This goes for an orbital with two electrons, except there is a second arrow above the line pointing downward. In the second method, electron configuration notation, a superscript is placed above the name and main energy level of an orbital. This superscript represents the number of electrons that are contained within an orbital. There are 2 electrons occupying each s sublevel, 6 electrons occupying each p sublevel, 10 electrons occupying each d sublevel, and 14 electrons occupying each f sublevel. The group 18 elements of the periodic table are known as the noble gases. A noble gas configuration refers to an outer main energy level occupied, in most cases, by 8 electrons.